So good morning to everyone. So in this last class we have seen the assembler loader linker. So in this class we are going to see about the program level performance analysis. While we made hope that the execution time of a program could be precisely determined. So this is a fact difficult to in practice. The execution time of a program often varies with the input data values because those values select a different execution path in the program. So for example, loops may be executed in a varying number of times and different branches may execute blocks of varying complexity. So the cache has a major effect on a program performances, and once again the cache behaviors depends on the part of data values into the input to the program. So the execution time may vary. Even the instruction level floating point operations are the most sensitive to the data values, but the normal integer execution pipeline can also introduce the data independent variables. So but the normal integers execution pipeline introduce the data independent variations in general. So execution time of a instruction in a pipeline depend to not only the instruction but the instruction around in the pipeline. So the some instruction microprocessor manufacturers supply simulators for the CPU. The simulator runs on the workstation, takes the input executable for the microprocessor along with the input data. So simulates the execution of the program. Some of these simulators go beyond functional simulations to measure the execution time of a program. So the simulation is clearly slower executing the program on the actual microprocessor, but it also provide greater visibility and during the executions. A timer connected the microprocessor bus can be used to measure the performance of executing section of code. The code to measure would be reset and start of the timer and its timer start and stop timer at the end of the execution. The length of the program that must be measured is limited by the accuracy of the timer. A logic analyzer can be connected to the microprocessor bus to measure the start and stop times of a code segment. So this technique relies on the code being to produce identifiable events on the bus to identify the start and stop of executions. So these are all the three type of executions: average case execution, worst case execution, and best case execution. So average case execution is a typical execution time would be expected typical data. So worst case executions and any type of input clearly important for system must be meet the deadlines. So the input set the causes the worst case execution time is obvious, but its cases not. The best case executions is a performance of multi-rate applications. We would consider a trace-driven performance based on the executing the program and observing its behavior. So this is a execution time, cache behaviors and pipelining performance. So the elements of program performance: execution time is equal to program path and the instruction timing. So the path is a sequence of instruction executed by the program. So the instruction timing is determined by the based on the sequence of instruction traced by the program path, which takes into an account dependencies, the pipeline behavior and the caching. Luckily, these two problems can solve relatively independently. Okay. So although we can trace the execution path of a program through the high level language specification, it is hard to get accurate estimate of a total execution time of a high level language program. A direct correspondence between the program statement and the instructions, the number of memory locations and variables must be estimated, and the result may be saved for reuse for recomputed on the fly. So among the other effects, so these are all the problems become more challenging as the compiler puts more and more effort to optimizing the program. So however, aspects of program performance can be estimated by looking directly to the C program. So if a program contains loop with a large fixed iteration bound, or get a code to rough idea these more time consuming segments. Okay. So the next one is data dependent analysis. If we consider that nested loop, in the sense it will create the degradation in the program performance. So thank you for this class. So in the next class we are going to see about the program level performance analysis. Thank you.